Hello students, do you know that carbon can form lot of compounds? Yes, we know the large number of compounds of carbon such that we have to make a separate branch of chemistry. Yes, we have the separate branch of chemistry, you heard it right. Carbon has lot of compounds that we have made a branch of chemistry known as organic chemistry. So when we talk about organic chemistry, what are we talking about? The compounds of carbon. That's why the name of the chapter is Carbon and its Compounds. So here we will be talking about what is this versatile nature of carbon such that it is able to make lot of compounds. So the question arises how carbon is making lot of compounds. So carbon can form large number of compounds, mainly organic compounds. So the term we use is organic compounds. Carbon compounds are known as organic compounds. Their main constituent is carbon. The main reasons are two: catenation and tetravalency. Let's talk about tetravalency first, because I am sure that you are already aware about tetravalency. As we know that carbon has atomic number 6. The configuration is in Kl shell, it is 2, 4. So it has 4 valence electrons, right? It has 4 valence electrons. And what is the valency? So carbon needs 4 electrons to lose or gain, right? So can I say the valency of carbon is plus minus 4, right? So carbon has valency 4. That's why we call it tetravalent. Tetra means 4. So 4 valency it has. So carbon has small size, it has 4 valency, which is actually helping it to make lot of bonds. So each carbon can make 4 bonds, right? Carbon needs to complete its last shell. For that it needs 4 electrons. So it shares 4 electrons with other atoms, right? Because I am sure that you know that carbon cannot lose or gain 4 electrons. That's why it shares 4 electrons. And why 4 electrons? Because it is tetravalent. It has 4 electrons already, it needs 4 more. So this is how tetravalency plays very important role in the process of making large number of compounds. For making large compounds, carbon is able to make so many bonds, 4 bonds, right? Now what about catenation? What is catenation? So children, catenation is a very important term in organic chemistry, because the entire compounds, they actually exist on the basis of this very important property called catenation. So what is catenation? The self-linking property of an element due to which large number of its atoms can be linked with each other of same kind or different kind by covalent bonds. So the main point here is it's a self-linking property. Carbons link with each other. They have self-linking property. Carbons can link with oxygen to make CO, to make other compounds. Carbon can link with nitrogen or similar atoms. So this is a self-linking property to make large number of compounds which is of same kind. What do we mean by same kind? Carbon can bond with carbon by a single covalent bond, double covalent bond or triple covalent bond. Carbon can make bonds with different kind of atoms, like carbon can make bond with oxygen, carbon can make bond with nitrogen. So isn't it a self-linking property? Yes. So catenation is very important key term. By this property only an atom is able to make lot of compounds, and they all exist by the formation of covalent bond, right? Sharing of electrons are taking place between them. So let's see the examples here. So when you notice the examples here, we have straight chain arrangement, branch chain arrangement and rings of different sizes. And see, they all are carbon atoms, right? So carbon has a linking property. Is it showing its tetravalency also? Yes, see, each carbon is making 4 bonds, right? These bonds are not completed because they will be completed by other atoms like hydrogen. But still, see, carbon is able to make bond with other carbon atoms. This is what we are talking about, catenation. So it can make straight chain structures, it can make branched structures like this, it can make ring-like structure, trigonal ring, it could be square structure, pentagon or hexagonal structure, right? So, such compounds are formed because of the property of catenation and tetravalency, and this leads to the formation of large number of compounds, and that's why we say carbon has versatile nature. So, now a very interesting questions come to our mind, and what is that? Carbon shows catenation, but silicon does not show catenation to the same extent. Silicon does show catenation, but not to this much extent which is like carbon. But still, the question is, carbon shows catenation, but silicon does not show the catenation up to the same extent. So, why we are comparing carbon and silicon? The question arises this first, that carbon has atomic number 6, the configuration in KL shell is 2, 4. So, why are we talking about silicon here? Because silicon has atomic number 14 and its configuration is 2, 8, 4 in M shell also. So, now look at the number of valence electrons they both have. Carbon has 4 valence electrons and silicon has 4 valence electrons. It means they both are tetravalent, right? You heard it right, that both carbon and silicon, they have 4 valency, they are tetravalent. Then what it makes carbon to have more catenation than silicon? Silicon does show catenation, but to a very lesser extent. It forms silicates. But what about carbon? Why carbon is winning here? Because carbon has small size. The point here is carbon has small size such that the carbon-carbon bond strength is very strong. They hold, the nucleus of the carbon holds the valence electrons of the other atoms so firmly, so tightly that they make stronger carbon-carbon bond strength. Here lies the difference. So, when we talk about silicon, children, silicon has larger size. Why? Because see, the number of shells carbon has only 2. The silicon has 3 shells. So, it has larger size comparison to carbon. So, silicon has larger atomic size comparison to carbon. So, due to its larger atomic size, the silicon-silicon bond strength is weak. Yes, it has weaker bond strength such that it is capable of doing the or showing the catenation, but to a lesser extent. So, who wins here? Carbon. Carbon has small size and strong carbon-carbon bond strength, due to which it can show catenation to a larger extent. I hope you have understood. Thank you.